My name is Michael Witchen. I'm an applications engineer here at ToloTalks, and thanks for coming to our ToloTalk. Today we'll be kind of talking over our rodless actuators and going through some of what we offer here. So, all right, let's get things started. So ToloTalks got an extremely broad variety of rodless actuators that we offer here, and rodless is really just a generic term to kind of describe, the actuator style. So in this scenario, these are going to be actuators that essentially can move a load back and forth, but they don't necessarily use like a piston style or a rod that's connected to, the form movement. Also, I will be taking questions at the end. So if you guys come with any while you're going through the presentation, feel free to ask them. I just will address them all at the end. So rodless actuators, you can see all of what we offer here. We'll go through all of these between today's and tomorrow's webinar. So I guess let's go on right away. So basically some key application requirements that you want to take into consideration when you're looking at rodless actuators are going to be kind of the load bearing, how heavy is the load that you're trying to move? Where is it offset? What kind of moments is that going to create on the actuator itself? Are you looking at gantries? Do you need multiple carriers, whether it's to mount to your load or how it's mounting to your assembly? And then what kind of speeds, stroke lengths, forces are you going to need? And also the environmental considerations. So is it a heavy particulate in the environment? Do you need to worry about various wash down elements? And those type of application requirements are what you're going to want to make sure you take into account while you're sizing up or while you're looking at these various styles. So to get started, we're going to jump right into it with our BCS series. So those of you that have used our BC2 pneumatic cylinders, this is actually a very similar style. It uses the same extrusion and the same carrier style as that cylinder. And as you can see, as we kind of look at this kind of breakdown, basically the carriage is pinched onto that extrusion using some Delrin bearings. So that's what's actually supporting most of the load here in this scenario. When you're going through and sizing, you're going to see there are three offerings, basically the 10, the 15, and the 20. That relates to the bore size of the actuator as well as everything else. So the BCS is going to be able to get you guys forces up to 2,700 pounds, loads up to 300, and then speeds up to 50 and so forth. Now, something that can be kind of confusing when you're going into this is, well, how can it handle a force of 2,700 pounds but only a load of 300? The load is going to be based on the FZ, and you'll get to that when we get to the moment loading as well. But so basically the weight that the carriage and the actuator can support by itself versus the force that the screw can produce are two different things. So the BCS is going to be a very cost-effective solution when it comes to electric actuators. You're going to be able to carry moderate load sizes. It's not going to be a super high-speed application, but you're going to be able to get quite a bit of function out of this unit, especially when it comes to like maybe a dusty or dirty environment. This is going to be something that you want to consider. Those solid bearings will be able to push out of the way most of that particulate or any sort of contamination. So it's kind of a self-protected actuator as well. Jumping into the next one, we have our MX series. So you'll see the next three series actually are going to look very similar, and that's because they all use a very similar extrusion, and then the carrier styles are actually what changes between them. So the MXE-S is going to be our solid bearing MXE. This is actually very similar to the BCS actuator that we just talked about. So similar to how the BCS has Delrin bearings, this also uses a wedge style or a trapezoidal bearing that pinches that carrier onto the extrusion. So the biggest difference you're going to see here is obviously the carrier doesn't fall as far down as the BC series does, and also it's a silver or aluminum extrusion, so that's going to just aesthetically look different as well. So when you get into it, the MXC and the MXBS are going to have a very similar carrier style. They're going to be cost effective. You're going to have the solid bearings that resist that environmental contaminants or the particulate that may be in the air. The solid bearings are also a low cost and field maintenanceable part. So as those wear over time in your application, those can be replaced fairly simply. We have got parts and maintenance sheets that go through the full assembly and disassembly process for these units. And for those of you that have been to a Tolo U or are considering coming to one, we actually get a chance to build one of these up yourself too. So that's something that kind of plays into, it's something that we can do here, you can do in the field as well. Now, there are also auxiliary carriers available, so that basically adds an additional carrier for moment loading or just standard loading capabilities. And you're also going to see that, you know, the YM program that some of you are familiar with, basically we've got a library of motor mounts that are available that can mount up to these actuators with very, very simple or with very little issue. So the MXES has also got, you know, its load capability here. So you'll see the moment loads vary with the 6 different sizes as you go up. Those go up as well. You can carry a max load of about 520 pounds. And you'll see that those bending moments also go up in a similar fashion as you get into those larger extrusion sizes. The auxiliary carriers are also very available to kind of double that moment loading capability and, you know, offer just another form of functionality with this MXE and MXB series. As you can see here, when you kind of compare them, the moment loading and the max loading goes up drastically when you go to that auxiliary carrier, mostly by a factor of 2, but when you get up into the MZ or that kind of rotational moment loading where the carriers are spaced out, you're going to actually have about a factor of 10 when you get up into those larger sizes. So that auxiliary carrier is definitely something to take into consideration if you can maybe utilize that instead of going up a size of the actuator or vice versa. So as we discussed before, to kind of recap, the MXES comes in 6 different sizes. You're going to get forces up to about 4,300 pounds, loads up to 520, similar speeds and moment loading as you see with the BCS series. And some might wonder why you would use one versus the other. Well, oftentimes you've got different screw availability options as well. So where you might have a small lead screw in the BCS series, you may have a larger option in the MX. So they can kind of fit in the areas where the other doesn't. So one application when we had with this particular actuator series was actually had to do with a CT scan that was built for horses and bovine creatures. So basically the challenges that we had to fit were they needed to be able to lift these 3,000 pounds. So the scanning head, and, you know, they needed to be durable for the environment because it was a very dusty, dirty, kind of grimy environment. This is something that they needed some additional support with. So they were actually able to work with our inside team here to come up with a solution together. So what we actually decided on were some of our MXE40s and MXE63s. And this was an option that provided the thrust that was needed for the application, you know, the quality performance. They could repair some of these in the field if need be. And we were also able to hit some pretty quick lead times for them because that's what they needed. So we were able to find, you know, a solution and work with them to help devise this kind of solution for them. Now, on the other side of that same solid bearing carriage is going to be the MXB. So this is our belt-driven version. So as you can see, compared to the MXE, where that screw is what's driving the carriage back and forth, in this situation, the motor is actually driving a belt and pulley system, which is going to pull that carriage from one end to the other. So if you zoom in, you'll see it's the same carrier or same bearing style and same carrier. The only difference being that this belt is what's actually attached to the carriage and pulling it back and forth along the extrusion. Similar to the MXE, you're going to have 6 different sizes all the way up through the 63. The forces are going to be a lot lower with a belt drive because all of that's being pulled just by the width of the belt. So the loads are going to be the same. You're up to about 520 pounds. Speeds are going to be quite a bit faster than available with a screw drive. That's because with a screw, when you're accelerating up to those higher speeds, you have to worry about the screw essentially gyrating, or you get some screw whip is what we refer to it as. Whereas with the belt drive, this isn't an issue. So you're going to be able to get much higher speeds with the same size actuator. So you've got your cost-effective solution. Solid bearings are going to give you that resistance to kind of the contaminant or particulate that's in the air, or in the application. The solid bearings are low cost, they're field replaceable. These are components that you can change out yourselves or stock so that you don't need to worry about sending this back or having a replacement. And then you've got auxiliary carriers and your motor here options as well. Another application win that we had with the belt driven unit was actually a pulp and paper processing. So they originally had pneumatics in there, but there was some pulp buildup and some clogging that was causing issues, and they wanted to remove all of them. So we were able to find a belt-driven solution that could meet the speed and control concerns that they had, while still offering, you know, a fairly accurate, fairly fast solution. And we could also avoid that clogging issue that they were seeing in this high pressure, kind of very contaminated area. So the MXB40S was what we ended up going with, and we actually opened the end caps on this one so that they could, so any of that pulp that was on the belt didn't actually just get clogged up in the heads of the assembly. And so it would just throw it off as that carrier went back and forth. And this was a really, really good win for us because we actually were able to find a lot of other applications that we could use this in as well. You know, film processing, web handling, all similar applications that use a similar type pneumatic actuator that could be replaced with a belt drive. Moving forward, we've also got our profiled rail version. So this is what we're going to dive into next. So the MXEP series actually uses a profiled rail that rides on top of that extrusion. You've got the same 6 sizes. It's all based on that extrusion, the 16, 25, 32, 40, 50, and 63. But this is going to get you a little bit higher load capability, and thrust capacity is going to be the same at 4,300 pounds force. So with a single carrier, you're going to be looking at, you know, 2.5 times as much capability than you would see with the solid bearing. You also are able to get a little bit higher speeds and a little bit shorter stroke lengths just based on that profiled rail. So jumping into this, you can see that there are actually bearing blocks that ride along that profiled rail on top, and this is what the carrier is attached to. And then it's obviously attached to the screw or the nut assembly as well in there. So these are going to provide a lot higher moment loading capability as well as just standard loading, just because obviously ball bearings aren't going to wear the same way a Delrin rod would. So profiled rail is going to give you a lot heavier moment loading and just loading in general. And you've also got those auxiliary carrier options still available in case you've got, you know, a large offset load or something that requires even more than just the standard profiled rail can handle. The one difference you'll see here is going to be that you are going to want to make sure the environment's fairly clean and dry. This is something that profiled rail piece is exposed, so we wouldn't want to have a bunch of particulate on that would gum up those ball bearings. So this is where if you do have a heavy particulate or contaminant area, you'd want to look at one of those solid bearing styles first before looking at the profiled version. Now, the belt is going to be the exact same. You're using those same bearing blocks on that profiled rail on top. The one difference you'll see here as compared to the solid bearing unit is the belt's actually running horizontally, and that's just based on the way it attaches to the carriage. So this is going to offer you a slightly different motor mounting option as well, because instead of being maybe left or right off of that pulley system, it's actually going to be up or down. Now, there are obviously options to rotate the actuator. In your application, you may be able to rotate and mount to that front face as well. So there's quite a bit of variability there in case we need to adapt to, you know, some sort of space constraint as well. Now, these use the same belts as the solid bearing units do, so you're going to have a very similar, you know, thrust capability. And you'll see here the force is up to 418. That's the same as the solid bearing. That's because it's based on the belt itself. Now, your loads are going to be, you know, right around the same 1292 as the profiled screw-driven version. Now your speeds are going to be a little bit faster because the profiled rail is going to slide a lot easier than those Delrin rods. So you can actually go up to about 150 inches per second with these. And you're going to have those high moment loading capabilities as well. Now here's kind of that moment chart that we had for the solid bearing. You're going to see that you can get quite a bit higher. There's actually comparison right here. So the same size actuator is going to have quite a bit more capability on the profiled rail than you'd see with that solid bearing. And that's simply because those bearing blocks are going to be able to handle that twist and torsion a lot better than, you know, the solid Delrin bearings that you have on the MXS style. All right, and last but not least for the MX series is going to be the MXVU. So this is an unguided belt drive version, and you'll see that this attaches the same way to the belt. There's a tensioning piece right in the carrier, and that's for all the different styles. But you'll also see that it's not actually attached to the extrusion anywhere. So this is kind of a free-floating carriage, and this is what we like to call almost like a garage door application. The MXBU is going to have to be pulling a guided load to and from because there isn't any moment loading capability with that carriage. So there isn't an MXE variant of this simply because you couldn't really have an unguided screw drive. But the MXBU does offer its own, application that it's particularly built for. Like you said, if you've got a guided load, you're going to have that same force capability as you'd have with the solid bearing and the profiled rail. The only difference being that it can't support the load itself. So you would need some set of guides externally, but if that was something maybe that was already included in the application, this is going to offer you a lower cost solution, low maintenance. You don't need to worry about the bearings wearing out because there isn't actually a bearing style here. But you get the same 6 sizes, the same force capabilities as you would with the MXS or P version.